Questions 21 through 25 on the 2014 Grade 12 AMC 12A. For every real number x, let x denote the greatest integer not exceeding x, and let f at x equal x times 2014 to the power of x minus 1. The set of all numbers x such that x is between 1 and 2014 and f at x is less than or equal to 1 is a union of disjoint intervals. What is the sum of the lengths of those intervals? This strange notation is actually not that uncommon. It basically means that you have any integer that is less than that number. So for example, if I wrote 5.4 and then I put these weird brackets around it, it basically is equal to 5. 5 is, of course, the greatest integer not exceeding 5.4. So what we are going to do is let x equal some integer with some decimal part. So for example, n is an integer, and n is going to be between 1 and 2013, right? Because x is between 1 and 2014. So we know that the integer part has to be at least 2013, but it cannot be 2014 because it's got to be less than that. And x is n plus r. And r is, of course, the decimal part, so r is just between 1 and 0. It's some decimal that's obviously less than 1. So now what we do is we take this f at x and we substitute what we have written. So now our f at x becomes the integer part of x, which is just n, multiplied by 2014 to the power of x minus, well, x is n plus r, so let me just put in n plus r, minus the integer part of x, which is just n, and then subtract that from 1. So this becomes just 2014 to the power of r minus 1. That's it. And we are told that we want this to be less than or equal to 1. So we want this to be less than or equal to 1, like that. Okay, so now let's work with this. N 2014 to the r minus 1 is less than or equal to 1 over n if I bring the n over to the other side like that. And then I can always bring the 1 over, so I have 2014 r is less than or equal to 1 over n plus 1. Okay, no trick so far, just basic algebra. Okay, so now what I will do is just simplify this part a little bit by getting a common denominator, 1 plus n over n, just like that. Nothing fancy. Okay, now at this point, I want to use a logarithm. So I can do that by using basic log rules that r will be less than 2014 as the base for the log, and 1 plus n to the n. As you can see, this will work out. 2014 to the power of r is less than or equal to 1 plus n over n, and therefore if you put it in log format, it will be like this. And also, don't forget that r, because of our definition up here, has got to be greater than or equal to 0. So, what does this mean now? This is true for all n that are between 1 and 2013. So for each of these, you're going to get some interval. So for n equals 1, this is going to give you some interval. For n equals 2, it's going to give you some interval. And because they're all from 0 to this number, each of them will have a length of that number. So when you add them up, all you really have to do is add up those numbers. All right? So let's do that. Let's just put the first few. So the first few, for example, for n equals 1, it would be log of 2 over 1 2014 base. And then the log for n equals 2, it would be 3 over 2 to the 2014 base. And similarly, for n equals 1, 2, 3, it would be 4 over 3 to the 2014 base, like that, right? And then you just keep on going, dot, 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 until you get to 2013 for the value of n, and that will give you 2014 over 2013 to the base of 2014. Now the log rule states that if you have the same base, you can combine them by multiplying them. So it would be 2 over 1 times 3 over 2 times 4 over 3, dot, 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 all the way until 2014 over 2013, like that. Well, this, as you can see, everything cancels here. The only thing that doesn't cancel is the very last 2014, and I guess the 1 at the end, at the beginning, if you really wanted to write it out. And this is all you're left with. And this, of course, is just 1. So that's it. That is the answer to the question. So number 21, the answer is A. The number 5 to the power of 867 is between 2 to the power of 2013 and 2 to the power of 2014. How many pairs of integers mn are there such that m is between 1 and 2012 inclusive, and 5 to the power of n is less than 2 to the power of m, less than 2 to the power of n plus 2, less than 5 to the power of n plus 1. Let's make a little list here, and that list will hopefully explain a few things. A few powers of 5, not too many. I think I'll just go up to 5 to the power of 4. That should be sufficient to explain what I need to explain. And that is 625. And then in between those, I've got to put in some powers of 2. But in a way so that they fit chronologically. So 2 to the power of 0, that fits, that's 1. But I've got to do it in a way so that it's greater than, right? Because I've got to go from smallest to biggest like that in order to explain this inequality. So I got to put 2 to the power of 1. 2 to the power of 2. 2 to the power of 3 has got to go in this interval because it's greater than 5. 2 to the power of 4 is 16. 2 to the power of 5 I've got to put here, 32. 2 to the power of 6 is 64. 2 to the power of 7 is 128. 2 to the power of 8 is 256. And 2 to the power of 9 is 512. Okay. So that shows me something that I need to use to explain this question. In between 2 powers of 5, we have 2 powers of 2. Here also 2 powers, but here we have 3 powers. And that is the scenario right here that allows me to satisfy this. The only way this is going to be satisfied is if you have 3 powers of 2 in between 2 powers of 5. So for example, this is satisfied with this grouping. So when n is 3, we have 5 to the power of 3, and that's less than m being 7, and that is less than 2 to the power of m plus 2, which is 9, and that is less than 5 to the power of n plus 1, which is 4. And as you can clearly see, that is illustrated right there. So in this case, my n was 3 and my m was 7. So here's one such pair that satisfies that. Now they want you to figure out how many of them are there for m between 1 and 2012. Well, as you can see from the answer choices, there's so many that there's no way you're going to do it manually like I have. So there has to be some sort of system. So here's the system. Let x be the number of intervals of 2 that contain 2 powers of 2. So for example, here's one such interval. Here's another such interval. Here's another such interval. Those are the number of intervals that contain 2 powers of 2. Now let y be the number of intervals that contains 3 powers of 2. So same thing, but this time 3 powers of 2. And there's one such interval right here. Now, how long am I going to go here? And that is where this part of the question comes in. that is where that part of the question becomes helpful for us, because they must have given it to us for a reason, that piece of information. So that tells me, that piece of information, that 5 to the power of 867 is between 2 to the power of 2013 and 2 to the power of 2014. So how does that help me? It helps me basically in this sort of format. So if I were to draw it out, it would be 5 to the power of 867. And according to that inequality, the 2 to the power of 2013 would be above it. So I basically have to figure out this scenario for this range going up, where it ends here. Okay? So for example, if x is the number of intervals that contain 2 powers of 2, let's just talk about it here first. How many of those such intervals are there? There's 1, 2, and 3. So that means in this scenario, x would be 3. If I asked you, in this scenario or this list, what's y? Y being the number of intervals that contain 3 powers of 2. Well, there's only one such interval. So y is equal to 1. And notice that x plus y is equal to 4. And that 4 is that number right there, because that 4 tells me how many total intervals there are. And in that case, there's 4. So that means that x plus y has to equal the total number of intervals. But for this example here, my total is 867. Right? Now we get into the next part, which is understanding something different. That is that the question now is, how many of these 2's do I have? Well, in this one, you can just count them manually. There's 9. I've just circled 9 of them. So that basically means that if you took your x, which is 3, and multiplied by 2, because each x contains 2 powers of 2, and then you took your y, which in my case was 1, and multiplied by 3, because each y contains 3 powers of 2, it would give you the total powers of 2, which in this case is 9, which is exactly what I had circled. So extrapolating that to this scenario over here, 2x plus 3y is equal to 2013. So a little bit of interpretation is required in this question. So now at this point, the question is pretty much almost solved. You just have to solve this basic system of equations. So when you do, you get x is equal to 867 minus y. Substitute that into there, and you get 2 times 867 minus y plus 3y is 2013. So that's 1734 minus 2y plus 3y is equal to 2013. And putting everything on one side, you get y is equal to 279. And that represents the number of intervals that contain 3 powers of 2. And those are the only type of intervals for which this is possible, like I had explained over here. So 279 is the answer, and therefore number 22, the choice is B. The fraction 1 over 99 squared is equal to this expression, where n is the length of the period of the repeating decimal expansion. What is the sum? b0 plus b1 up until bn minus 1. 1 over 99 squared, or 1 over 9801. Now, this is painfully long way of doing it if you do it, without a calculator, because calculators are not allowed. And I also am certain that you do not want to hear me go through 1 divided by 9801 the long way, where you put it here and 19801, that is going to be painful. So what I'm going to do is just write out what it actually is. So this is the monster that this basically becomes when you expand it out. And I'm always amazed at how time-consuming these questions can be in the latter part of the AMC 12. You've got 3 minutes. How on earth are you supposed to be able to get this in 3 minutes? But in any case, I mean, just looking at it gets me, exhausted. But let's talk about this now. So what are they asking? They basically want you to add up the numbers. So all of these digits that you see here, they want you to add them up. And then what is the sum? Okay, well, let's look at what it actually is. It looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on, right? And it looks like it covers every single number until you get to the very end, and you notice there's no 98. So, very challenging question that somebody would have to actually do all of this, because you can't just stop. You can't just, most people, even if you did the first few and you get to like here and you say, oh, it looks like it's just the same numbers over and over again in a consecutive way, right? 1, 2, 3, 4, 5, 6, and so on. But you would have to literally get to the very end to discover that there's one missing digit, that there's no 98. All right, and then after this, it just repeats itself. It starts like this, and that's what this symbol means right here. Okay, so let's just add up all of the numbers from 1 to 99. But actually, that's not what they're asking. They're asking you just to add up the digits. So it's a little bit different. Adding up all the numbers from 1 to 99 is actually very easy. You just use that formula, n times n plus 1 over 2. But that's not what they're asking. They're asking you to add up the digits. Okay, so let's add up the digits. Let's make a little table. From 0 to 9, that's just 1 plus 2 plus 3 all the way till 9. That's pretty straightforward. That's just going to be 9 times 10 over 2, which is 45. And then from 10 to 19, again, each of these is going to be valid, but you're also going to have 1 in each of those digits. You have a 1 in 10, 1 in 11, like that. So it's going to be 10 times 1, and then plus that 45. And very similarly, from 20 to 29, it would be 10 times 2 plus 45, like that. And then it just keeps on going like that until you get to 90 to 99. It would be 10 times 9 plus 45. So this one is 45 basically, and then you can just sum it all up. So it would be 10 times 1 plus 2 plus 3 ... all the way up until 9. And then 10 times 45. And that is 10 times 45 plus 10 times 45. So that's 450 plus 450, which is 900. But remember, there was no 98, if you can see there. So we have to take away the fact that there was no 98. So we have to take away a 9 and an 8 from the sum. So from 900, we have to subtract a 9 and an 8 because we can't add those two digits. And when you do, you get 883. So that is the answer to this. That would be B. Let f at 0 at x be x plus the absolute value of x minus 100 minus the absolute value of x plus 100 for n greater than or equal to 1. Let f at n at x be f at n minus 1 at x minus 1 for how many values of x is f at 100 at x equal to 0. First, let's look at this equation right here. F at 0 is equal to x plus the absolute value of x minus 100 minus x plus 100. Now obviously there's going to be some intervals, so let's figure out what this is going to be for each of those intervals. And the first interval is when x is less than 100. When that happens, it will change this expression. We have to drop the absolute values to get sort of a understanding. It will be 100 minus x minus minus x minus 100. So that becomes 100 plus x plus 100, and that is equivalent to 200 plus x. Okay, so that takes care of the first scenario. The next is when x is between 100 and negative 100, like that. When that's the case, that expression up here becomes x plus 100 minus x minus x plus 100. And this simplifies to x plus 100 minus x minus x minus 100. And that is just going to be minus x. And then the last scenario is going to be when you have the following. X is now greater than or equal to, when x is greater than or equal to 100, it becomes x plus x minus 100 minus x plus 100. And this simplifies to x plus x minus 100 minus x minus 100. And that becomes just x minus 200. So there we go. Those are our three values for our three different intervals for this right there, f0 at x. Now we have to talk about this expression right here. What does this behave like? When we get an understanding of what it behaves like, we will be able to explain the remainder of the question fairly easily, I believe. Well, let's start with some sort of value for f at 0 at x. And then we can put it in here and churn out the values. So let's say let's start something small because we're trying to get to 0 for f at 100, right? So I think you're subtracting 1 every time. So you're going to get to 0, I guess, just by subtracting 1. But let's see. Let's say we started off at 3. That means f1 at x would be this minus 1, which is 2. And that's all it is, really. And then f at 2 at x would be 2 minus 1, which is 1. And then f at 3 at x would be 1 minus 1, which is 0. F at 4 at x would be 0 minus 1, which is negative 1. F at 5 at x, now the absolute value kicks in. When you put negative 1 into this, it becomes 1 when you take the absolute value, and then 1 minus 1 is 0. And then f at 6 at x would be back at negative 1. F at 7 at x will be back at 0. Yeah. So this now just keeps oscillating between 0 and negative 1, as you can see. So that means you're going to eventually get down to 0 if these are odd. But the problem is that our f at 100 is even. So that tells me that I must start at f at 0 x being an even number, like 4. And if I did that, then once I go through this process, I will get to a 0 for f at 100, like that. And I'll just write them out just to sort of convince you. 2, 1 for this one. F at 4 would be 0. And then f at 5 would be negative 1. F at 5 at x would be negative 1. And then f at 6 would go back to 0. And as you can see, whenever the number for f is even, it becomes a 0. So if you kept going ... like that, f at 100 of x would be 0. So that is the criteria, that f at 0 at x must start with an even number. So that's a very important thing to figure out. The other thing that I need to illustrate is what happens if we started with a negative. We started with positives, right? But what happens if we start with a negative, like say -4, like that? Well, let's see. F at 1 at x would be, put -4 into here, you get 4. 4 minus 1 is 3. F at 2 would be then 2, and as you can see, it will behave exactly like what's beside it. It will just be the same story, because the very first one, this negative is canceled out by that absolute value. So what that makes me think is that it can be negative or positive as long as it's even, that first f at 0. Okay, so that's the first piece of information that we need to understand. Now, where do I start? That's the next question. Here I started with very small numbers, 3, 4, -3, but obviously these answers choices are pretty big. So where do I start? And obviously the thing is, right, you have to get down to f at 100 being 0. So if you started all the way, for example, at 100, like that, eventually when you get down to f at 100, it would be 0. But if you started more than 100, like if this was 400, you're only going to be able to subtract 1 each time, so you wouldn't be able to get down to 0. You get down to 300. So does that make sense? So it has to start at least at 100 to eventually get down to this. So that means, in summarizing, f at 0 at x must be an even integer, and the range is that f at 0 at x has got to be between 100 and between -100. So this is our rule, and that is what we are going to apply in this question to figure out how many values of x give us that equal to 0. And we're going to use this guy right here. And here we go. So for the first one right here, this one, I have to abide by this rule here. So that rule states that f at 0 at x has got to be between 100 and -100. Well, f at 0 at x here is 200 plus x. So I put that in there. 200 plus x is between 100 and -100. And that is true only when x is less than -100. X is less than -100, like that. Okay, let's isolate just for x in this one. So I guess we're subtracting 200 from both sides. So this would make this -100, and this would make this -300. Okay, that's our first range for x. Now let's do the exact same thing for this range now, right here. For that one, again, f at 0 at x has got to be between 100 and -100. And that means -x has got to be between 100 and -100. So x can be a negative integer, as you clearly saw over here, as long as it's even. So the fact that you have -x shouldn't worry you. That's perfectly fine. We just have to make sure that at the end we only take the even values of x. So this gives me another range for x. It's between -100 and 100. And now let's look at the final range, which is right here, when x is greater than 100. That means we have, again, f at 0 at x is between 100 and -100. But this time it's x minus 200. That's the value of that. So there we go. And this is going to be, if you add 200 to both sides, x is going to be between 300 and 100. So now we have to combine all of these. If you combine all of these, that means x is between minus 300, and it looks like we're going all the way to 300. And remember, x could be negative also. So this is perfectly fine the way it is. We don't need to worry about that. So we have x is between negative 300 and 300. We only want the even ones. So there's going to be 600 numbers divided by 2, so 300. But remember, there's also a 0 in there, plus 1 for the 0. So that gives you a total of 301. And that is the answer to this question. Number 24 is C. The parabola P has a focus 0, 0 and goes through the points 4, 3 and negative 4, negative 3. For how many points x, y that are part of the element of P with integer coordinates, is it true that the absolute value of 4x plus 3y is less than or equal to 1,000? First thing I'd like to do is draw this diagram and let's discuss it a little bit. So it's not going to be beautifully drawn to scale, but I'll try my best. So here we go. And then let's just use the information they give us. 4, 3 and 3, 4, so approximately here. And negative 4, 3, so here, approximately. And that is the 2 points. So let's just draw a line connecting them like that. Now very quickly, because this is 4 and this is 3, I know that this is going to be 5, right? Because that's a 3, 4, 5 triangle. And the same story here. This is 4 and this is 3, so that's going to be also 5. So that hopefully will help us. They made it a little bit easier for us with that 3, 4, 5 right triangle. Okay, now what I have to do is I have to draw this parabola. The focus is right here, 0, 0. So this is 0, 0. Obviously, that's the origin. I'll just put a little F for focus right there. And we've got to draw a directrix. Now, the directrix depends on how the parabola opens. Does it open like this or does it open like that, right? And that's something I honestly don't know, but I'm going to do the solution the correct way. And that is basically a parabola that opens like this. So something like that, in a very sort of very sketchy way. Okay, so now what we have to do is you have to draw the directrix. So how do we do that? The directrix is basically a line. It's going to be something like this. And where it exists is basically that the distance from any point on the parabola, so let's say this point to the focus, is the same distance as the point to the directrix. So the directrix has got to be somewhere along there. So let's just draw an approximate place for that directrix. So approximately there. And just to recap, the distance from this point to the directrix has to be the same as the distance from that point to the focus. So the distance from that point to the focus is 5, so this distance has to be 5 also. Okay, and this line is the directrix, like that. And then the good news is we can approximate these points, that point, and of course the point on the other side, which is right here. We can approximate that because it's 5 in distance. So if I were to draw sort of a sketch, if I'm going 3 this way, 4 up, I'll be able to figure out that point. And 3 going left and 4 up from this point right here would basically be 1, 7. So this point is 1, 7. And in a very similar way, we can sort of say, since this is 5, 3 3, 4, 5 triangle would basically be going up 4 and going across 3 from this point. So if you go up 4 from that point and across 3, it would be minus 7, 1, this point right here. So there we go. We got 2 points, and then we can find the equation of the directrix line. And the directrix line, I'll let you do that. I mean, there's 2 points, and as you know, all you have to do is sub in those 2 points into y equals mx plus b. And you'll get the equation. And when you do, you get the equation y is equal to 3/4 x plus 25 over 4. That's the equation of this line right here. That's the directrix. Multiply through by 4, and you'll get 4y is equal to 3x plus 25. All right. Now at this point, we have to talk a little bit about something very important, and that is the point line distance formula. The shortest distance from a point to a line is the perpendicular distance. So if you have a line that has this equation and you want to figure out the distance from a point to that line, which is represented by d for distance, it's this formula right here. So I have to apply that to this equation right here. And then in particular, let me draw in the diagram what it is I'm referring to. I'll just draw one such point. So let's just say right here. So something like that, that red line, or any shortest distance from the point to a line. So for example, from here to here, let's say, if the point is here, from here to here. And of course, these are all going to be right angles like that. Okay, well, applying this formula, it would basically be d is equal to, and remember, this is my line this time. So let's put this all in one side because we have to get it in this format. So it would be 3x minus 4y plus 25 is 0. Okay, so using this formula now, d is equal to 3x minus 4y plus 25, the absolute value, over the square root of a squared, which is 3 squared right here, and b squared, which would be negative 4 squared, like that. Okay, so no trick so far, just that formula. Now, here's the part that is a little bit tricky. Let's say this point right here is xy, right? That point right there. Well, just like how they put xy right here. I'm interested in this whole parabola. I want something that's true for the entire parabola. And any point xy like that. Now, this is not perfectly drawn to scale, so it might be a little bit harder to understand. But let's just recap that any point on the parabola, if you draw a line from it to the directrix, like I have drawn right there, and then you draw a line from the same point to the focus, like that, those distances have to be the same. So it's probably best illustrated in the one that is labeled 5, right? This point right here is best illustrated in terms of the way the diagram looks. So that point, for example, is 4, 3. If you drew a line from that point to the directrix, the distance is 5. If you draw a line from that same point to the focus, the distance is 5. And that's true for any point on the parabola if it was perfectly drawn to scale. Now this point is represented by 4, 3, but in general it's xy, right? So if the distance from xy to the directrix is 5, I can also call that d, just like I call this d right here. And the distance from here to here must also be d. In this case, it's 5. Now, here's the thing. Look at this d right here. That d and this xy have a relationship. This is x, this is y. What's that relationship? A Pythagorean relationship. X squared plus y squared is equal to d squared. And that is a very important aspect to this question because it allows you to substitute x squared plus y squared over here. But remember, we're substituting for d squared. This is not d squared, this is just d. So we have to square this whole thing in order to make it d squared. So it would basically be 3x minus 4y plus 25, absolute value, all squared. And then the bottom, when you square it, the radical sign just disappears. So it just becomes 3 squared plus 4 squared. All right? And this is the equation that's going to help us solve the question. All right, we've gone down to a very, very good point in this final question. Now, we have to rearrange this. And you do some algebra and to rearrange it. And then when you do, you get the following. You get 4x plus 3y all squared is equal to 25 times 6x minus 8y plus 25. Now, at this point, we have to backtrack and look at what the question is asking. It is asking that if you have 4x plus 3y less than 1,000, for how many points can you get integer coordinates so that this is true? All right, well, let's see. In order to make this a little more digestible, this part here I'm just going to call m for now. So this boils down to just m absolute value is less than 1,000. And since we've got a bunch of 25s in here, I am going to write m is equal to 25k, and that will help me simplify things a little bit better. And then substitute that into this guy right here. So when you do, you get m right here, but that is 25k. So it'll be 25k all squared, and this is 25 times 6x minus 8y plus 25. Now the 25 squared will cancel 125 with that guy, so we will just get 25k squared is 6x minus 8y plus 25. And this will be my equation 1. My equation 2 will just be this one right here. Right here, where in particular 4x plus 3y is equal to 25k. That is my equation 2. 4x plus 3y is 25k. And now we have to solve these two. So solving, we get x is equal to 1/2 3k squared minus 3, and y is equal to minus 2k squared plus 3k minus 2. And the values of k that make x, y have integer coordinates, if you look at these two, you will see that those are odd integers. And therefore, for this range, which was 25k less than 1,000, if you look at what we did up here, those values of k are k equals minus 39, minus 37, minus 35, ... 35, positive 37, 39. And when you add up these guys, those give 40 values. So 40 is the answer to this question, and therefore number 25, that is choice B.